My name is Andrija. I'm Senior Cloud System Engineer within HIAG Data, and over here we have Mike, who you probably know.
Yeah, I'm Mike Tutkowski. Been in the CloudStack community for about 5.5 years now, on the PMC for about 4 years, and I'm the current VP of Apache CloudStack. I actually have a very minor role in this particular presentation, as Andrija has pretty much collected all of this information on his own. I have a small part later, so I'm going to disappear for a while and come up around in the middle of the presentation for 5-10 minutes. So take it away.
Yeah, thanks. So basically this is going to be a short story of, let's say, or kind of sharing experience from our side as we grow up from well, at the beginning, obviously, a startup mode company, what kind of issues we experience with the CloudStack, with storage, with our infrastructure, and so on. So basically, the growing up issues, you can say, and then how we basically solved it and how we now transition to using the managed storage or the SolidFire solution. So let's move on. Just a bit of storage history, but previously I would just mention we are running purely KVM. Advanced networking, so VPC stuff, no basic zones, nothing. It's purely, let's say, VPC. We ended up using at the moment a 4.8 release with a lot of, let's say, changes, internal fixes, and so on, improvements. So I'll try to be a bit quick because we lost some unexpected time. Originally, we basically, when we were in a seriously startup mode, let's say, we had certain amount of hardware and we said what kind of storage can we do that can provide us some nice features. Obviously, we went with CEPH. A bit later, we went with NFS, expecting a bit more performance, a bit less, let's say, integration problems. Eventually, we went with a, let's say, full SSD-based NFS solution. This is, as you can read, a do-it-yourself solution, so this is not NetApp or anything similar. There has some drawbacks, obviously, but it's also pretty good. You know, the integration into CloudStack is probably the best one among different primary storage solutions, but still there are some shortcomings. So in the next few slides, basically, I will speak about the different set of challenges and issues which we experienced during this period of using CEPH and NFS, and then how we transition to moving managed storage. So the next few slides, don't observe them as some kind of complaints. That this is just honestly sharing some of the issues which we had, and later how we solve them. So we'll basically speak about stability, performance, and the usability and management challenges or issues. I need to mention that most of the stability issues are fixed, especially some of the things are actually very well addressed in the 4.11 release, which Paul previously explained. We will speak about that later as part of this. Performance may obviously vary depending on your hardware and what you use in your setup, and usability and management wise, some features stay, some features are being improved, and that's pretty much it. So briefly on stability, we originally faced an issue when any kind of exception in librd, which is basically RBD client library for talking to CEPH from the libvirt, would basically crash. So any kind of exception would cause agent to crash. And this is what Paul mentioned previously, that you cannot know if your VM is really running now or not. And since we enable at the moment VM high availability, CloudStack will go and start the VM on another host, while actually the VM is still running, so you would get storage corruption for the volume of the VM. Very nice and convenient. So all these issues are basically resolved in the meantime, or at least most of them. So if you go together with CEPH, at least on stability and issue-wise, you are in much better shape. That needs to be said. CEPH rebalancing deep scrubs, we'll mention it as well on the performance, let's say, section, but basically, any kind of data rebalancing, which is moving data internally between CEPH nodes for any reasons, repairing data disk, or rebalancing data for any reason, and the deep scrubs, which are basically equivalent to low file system file checks on the hard drives or SSD drives that you use in your CEPH cluster, can impact client I/O. Originally, due to our own, let's say, we can say mistake, or at least less than optimal sizing of the CEPH cluster, and combined with deep scrubs, we ended up even in some situations that happened only once, but was very funny that client I/O wasn't served for 100 seconds. And you can imagine that client VMs would go to read only, and you say, crap. It was really fun. This was the very beginning of our, let's say, storage issues. Then also flapping monitors and OSDs in CEPH due to different network issues can also cause slow requests. Same, let's say, stability penalty. Flapping is the official terminology for going up and down, basically, and monitors and OSDs are object storage daemon in CEPH. Let's say hard drives and monitors which are monitoring the whole infrastructure can go up and down, and CEPH can become really crazy if you have issues with network devices, cables, switch ports, defective firmware like in our case, and so on. So just be aware that CEPH is very sensitive to network. Make sure it's stable. Volume snapshotting can then also take a long time to complete, simply not really the snapshotting process, but the process of copying over the snapshot to the secondary storage, and this is now a very nice improvement that Paul mentioned previously. They're being decoupled, so when you execute APR for creating snapshot, it will almost be instant. It won't last for 2 hours, 3 hours, because you imagine 1 terabyte volume, somebody creates a snapshot, it's being copied over to secondary storage. We had customers like that. And then simply because this is executed in sequence, you can read more at the last slide. I provided a set of links where you can read the description of the original issues. Basically, this will block the job queue for the other tasks in the agent queue on the same KVM host. So for example, you might end up in a situation when you cannot start virtual router because the snapshot is running. It's kind of silly. But this has been obviously addressed, at least this specific issue, and there are some improvements being done on the snapshotting sides as well, in general, on CEPH and KVM, or actually in KVM in any way. Then also, I mentioned we use the NFS do-it-yourself solution, so not enterprise. It was based on ZFS, and we once went to a kernel panic, which is basically my last name. Basically all agents rebooted themselves at some point in time because agents usually assume that you have a good quality and
1 2 1 2 1 2 1 2 hey ja 1 2 hey hey
okay, that's not
hey,
me.
Hey 1 2 do 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 do.
Good. That's my stomach. Yeah, good. Yeah, I guess I can. It's okay for you, or? Yeah. Can I continue in the meantime, or let them play Macarena or something? So at least I know that one. Anyway, back to the topic. So back in the days, this was again let's say first year of our cloud operation. Due to the KVM heartbeat script, which basically writes to the primary storage, we're talking actually about NFS only for now implementation, agents assume that you have a stable, highly available storage, and if there are issues writing to the storage, agents assume that they are the ones that are in problem. So agents would say, okay, I'm the stupid guy, let me reboot myself. And because it was actually a storage issue, all agents rebooted themselves. Very funny experience, to be honest, but still we didn't have too much clients back then, so it's okay. Then if we moved forward to the performance, I already mentioned briefly rebalance dip scrubs and flapping OSDs or monitors can cause serious performance issues. But basically what you can do to solve this is you can throttle the rebalance process, which means that it takes literally days to finish, but it's much less impact on the client I/O, so you don't have let's say penalties. In that sense, disable dip scrubs, believe it or not, we had to do this because simply when you do a low file system check across drives, we still end up with having blocked I/O requests. Replace OSDs if the drive is about to fail, or network devices. We recently, after some maintenance, had issue with defective cables, defective switch port, and maybe something else, and basically CEPH was going just up and down, and it was causing a hell of a lot of blocked I/O requests. Actually, not recently, but yeah, during the last maintenance that I can remember. So make sure that your network is okay. Then this is performance, not necessarily penalty, but we couldn't use improvements that are in general possible. When you are using client libraries or client side to talk to the CEPH cluster or to write to the CEPH cluster, basically you can define it, you can say to the CEPH, I want to stripe my data across multiple objects. So literally imagine RAID 0 across 5, 10 devices. In RAID 0 it's not really redundant, obviously, but here you can basically define the stripe size. So imagine you're writing, I don't know, 40 megabytes of data. You can write it across, theoretically silly numbers, but you can write it across 10 objects of 4 megabytes, and these eventually, and in the best possible scenario, will be written to 10 parallel drives, or 8 or 9, depending on the placement groups and everything. But in Librados, there was no yet support at the moment when we were using it, so we could not make let's say we could not make a better performance, so we use default, let's say, so to speak. Then also one huge issue at the beginning is that there was no proper CEPH snapshot removal process. So basically you create a snapshot, it's being copied over from set to secondary storage. When you want to delete the snapshot, CloudStack will delete it in database, it will delete it on secondary storage, but there will be left CEPH snapshot on primary storage. So imagine hourly snapshots, which is 24 snapshots per day times a couple of days. You end up having like 5,100 snapshots on the primary storage. And I will mention this later as well. This causes huge performance penalty. What we temporarily did, we just hidden the hourly snapshot button and kindly asked our clients to stop doing hourly snapshots until the things are fixed. And then we eventually implemented proper CEPH snapshot removal code. This is our, as I wrote, humble contribution to community. We didn't contribute maybe too much, but at least this useful part is there starting from 4.8 release. Then if you continue with performance, whatever kind of shared environment you use, network storage doesn't matter. If you don't have proper quality of service, you will eventually end up with the noisy neighborhood scenario. So basically, when we are now speaking purely about KVM, so I'm referencing KVM as well, actually only KVM here. When you create your disks on shared storage, there is actually a quality of type set to hypervisor, which will basically generate just the limit, let's say the read and write rates in either bytes per second or IOs per second, whichever limit is reached first. These are not 4K IOs, these are any size IOs. We will show you a nice demo, hopefully after this, let's say, text part of the presentation. This is for some reason not applied to the hot plug volumes. So, you know, imagine a client who wants to benchmark your storage up, touch 10 volumes, do RAID 0, and then kill the storage. It was very fun back in the days. For me personally, this is not really true quality of service. It's more like damage of control of a kind, but it's still much better, obviously, than not having anything. So this is still good enough to avoid at least most of the noisy neighborhood scenarios. Now a bit of, I wrote it here like to be funny in theory versus practices exercise. Imagine you have 100 client VMs which have optimized their I/O for, let's say you are doing, I don't know, some sequential writes, or if you're using CEPH, you do RBD caching on the KVM side. So you have 100 purely sequential streams that you send to the storage. CEPH, NFS, doesn't matter. So in general, any kind of storage can very well handle sequentially. You agree, you know, hard drive can do almost 200, single hard drive, 200 megabytes per second, but in the 4K random I/O, it can do barely 400 or 600 kilobytes. So it's really, but the problem that happens is basically that at the back end on the storage, you have too much streams interleaving, and this becomes absolutely 100% random I/O. And this is the reason basically that any kind of hard drive solutions with no matter what kind of magical caching you actually use become absolutely useless, and that's the time when you actually need to employ SSDs and use the random basically I/O power that it provides. There is actually very nice, you can, okay, my laser is dead. There is very nice actually white papers from Intel how to reach 1 million IOPS with Intel and some software solution that will actually back up this, exactly this theory. Moving forward on usability and management, what I briefly mentioned previously as well, there was actually snapshot lifecycle issues when talking with CEPH, and then due to the certain RBD layering issues, we end up having serious performance degradation across whole CEPH cluster, not just the volumes which had the snapshots. We even implemented some custom snapshot deletion script, which will basically clean up any unreferenced snapshot from CEPH, and later we implemented a code which I already mentioned. Now, to make things even more fun for us at the same time, there was a certain issue, variable size or something similar in Rados Java 0.1, where if you have more than 16 snapshots, it will basically crash. When you want to delete the volume, which is on CEPH, basically the Rados Java will try to unprotect all the snapshots, and then you try to list me all the snapshots, and you have more than 16, it will just collapse. It cannot handle more than 16 snapshots, so basically this is the time where new version was implemented by Vido. Some of you who are on the community list actually know him, Vido Den Hollander, and big thanks to Vido for fixing this, because this was basically combined with this above issue, and it was very pronounced for us. You know, whenever customer deletes the volume, we have agent disconnection, we have VM downtime. So a lot of VM downtime with CEPH, but not necessarily because of CEPH. It's also combined with, let's say, our own maybe mistakes as the process of learning it. Snapshots already mentioned. Imagine we actually did have a customer who was trying to snapshot 2 terabyte volumes, but they're being copied over to secondary storage. Imagine a scheduler on huge volume. That means that you have all the time terabytes and terabytes moving from primary storage to secondary storage. If one of the snapshots, because of the timeouts, becomes broken, it's stuck in an allocated state or some intermediate state, it's not fully finished, then it will actually break the snapshot scheduler in general, and you need to go to database, dig, clean up things, and so on. So you need to basically educate customers. These are not really snapshots in real reality. These are more like volume backups, which we will touch a bit later. Continuing with snapshot, when talking about NFS and CEPH, there is no actually possibility to revert back these resources to a snapshotted state. So there is no revert back. There is only not only that's good enough, when there is no better solution, you can provide provision new resources, or so VM template from the root volume snapshot, or data, new data disk from the data disk snapshot. And this actually takes time, obviously, and also a bit of billing issues for the customer. Some minor things is like improper file extension when you download volumes, and improper file type in database, which later causes different issues. This was basically all locally fixed, and I also believe it's fixed in the meantime in the upstream. So again, this is all like 3 years old issues, but I'm just describing you my, or actually our fun, not mine, sorry. Then a very important topic is a volume migration between different primary storages. If you're using Zen or VMware, you have this nice vMotion, ZenMotion, so on, things that you can basically live migrate your volumes from one storage cluster to another storage while the VM is running, so no downtime during moving volumes from one storage to another, which is very nice thing to do. For KVM, there was only so far possibility to do offline storage migration. Basically, you need to stop the VM, migrate all the volumes, which can take hours in some cases, and then start the VM, and then customers are not really happy because of the downtime. And now this is one of my favorites, and we will have a demo, combined demo actually a bit later. There is nothing special about this case because it's so common, or at least should be very nice and with no problems. VM Live migrations, which is basically, let's say, RAM memory migration, has nothing to do with storage at this point in time, but later you will actually see how and why it has something to do with it. If you have a busy VM, which basically means the VM which has a lot of a high RAM memory change rate, so busy SQL Server, for example, which we experience with Microsoft SQL and so on for some high workloads. If there is a high RAM change rate, basically the Qemu migration thread cannot catch up with the amount of changes that this VM is doing to its RAM memory, and basically due to this you cannot actually put your host into maintenance mode, which is kind of really silly, you will agree. So, you need to do some kernel Qemu upgrades, whatever. You cannot put the host into maintenance mode. You can below read, I will not spend some time right now, but you can below read an extremely simple way how to artificially, obviously, reproduce a busy VM and just watch it being migrated forever. But how we actually solve this, I will speak later in more details. We're basically employing the dynamic auto-convergence from Qemu, which basically dynamically throttles the CPU more and more and more and more, as enough basically that the busy VM is not so much busy anymore, and then its RAM change rate gets slower or low enough at least, and then Qemu can actually finish the migration. This is just a funny rate of changes per second. This is gigabytes, not gigabits, gigabytes. You will see this in a demo as well, and it works. I will do it later. So this is part of the presentation where I'm supposed to be funny because I don't have nice graphics, squirrels, penguins, nothing. Since this is open source, it's a bit a boring presentation, so failed attempt to be funny. How can we solve all these challenges? We can basically stop expecting high I/O performance or stop using QoS, who needs snapshots, live migration, anyone. Or we can basically become, let's say, serious and see how to actually really solve these issues. You can solve this in a certain ways by, obviously, even with our current storages, but what we do, we basically, somehow it happened that we combined solution to many different problems together with going with SolidFire at the time where we transitioned to moving SolidFire. So Mike, this is 5 minutes for you. Yeah, Mike will basically tell you a bit about, in general, about SolidFire, and then I'll take over for the rest of the presentation.
Now, I can't remember, is the next slide?
It's
maybe
all,
let's just kind of page through these.
It's same slides, yeah.
Yeah.
It's
All right.
one.
So yeah, I work at SolidFire. It's been 2 years now since it was acquired by NetApp. The main thing that I've done in the CloudStack community in the 5 or so years that I've been involved with CloudStack is bring quality of service to the CloudStack cloud environments. So as Andrija was mentioning, CloudStack was never really built with the concept of quality of service in mind. It was always designed around either NFS or maybe really large iSCSI volumes that you might put a clustered file system on and then have your virtual disks share that clustered file system. But there was really no planning around quality of service, which is a critical component in any kind of a cloud. You don't know what other people who are sharing those storage resources are up to from day to day. So if you have mission critical applications in some cloud, it could turn out that that application is running great one day, and then the next day the performance is tanked because other people are utilizing the cloud more heavily, and just from day to day you really don't know what to expect from your storage performance without having some kind of guaranteed quality of service. So that's where SolidFire comes into play and what I've been working on in the CloudStack community over the years. We'll see in some level of detail through demos in a moment how this actually looks in practice, but from just a high-level point of view, the idea here is to be able to deliver guaranteed storage quality of service to the virtual disks of each and every VM in your cloud so that you don't have to worry about what other people, maybe people you don't even know, they don't work for the same company as you don't know who these peers are who are sharing your cloud environment. Well, it doesn't matter if you have a robust quality of service system backing that cloud. You have guaranteed performance on each and every one of your virtual disks, and you don't have to worry about what everybody else is doing in the cloud at all. So I will leave it at there and let you continue on with the rest of your presentation.
Sure. So you can basically read a bit of details here, but these presentations will be also online, so you can maybe read in a more, in a more piece, let's say. I would like to move forward if that's okay, but Basically, what you have the option to guarantee via the minimum IOPS property of a volume. We will see this in the demo. You have the option to make a 100% guaranteed performance in normal and in the most faulty conditions, including maintenance, cluster expansion, replacing the disk, SSD health checks, which are maybe equivalent to CEPH disk scrubs, and so on, basically because part of the IOPS is, let's say, sold or offered for the end user customers. Part of the SSD IOPS is reserved for internal purposes, so it's very transparent. During any kind of maintenance, your performance is not degraded. Last but not the least, no special external library, because at the end, SolidFire volumes are basically just iSCSI LUNs connected to the KVM hosts and just passed through all basically like a local disks to the VM. So no way to actually have liberty issues like we did have originally back in the days with the libRBD, which is required to communicate to the CEPH cluster from libvirt. So basically, these are a list of some of the improvements of the managed storage, which was also mentioned briefly by Paul. A lot of these are basically come from the HIAG, and you can also see this is not necessarily meant to be a really commercial for SolidFire. So some of the things are also missing over there. Some of the, I don't want to say basic things, but some of the things that we could do with NFS and CEPH. Now when we moved to SolidFire, we could not do some of these things. So these were all these features which were basically missing are now improved or implemented actually by Mike. And one of the more important ones was offline storage migration, and eventually the online storage migration, which is, let's say, equivalent to the vMotion or ZenMotion for KVM. Inside the CloudStack, this is actually an absolutely new thing inside CloudStack at KVM World. Proper auto-convergence and so on, we will basically speak about that. But basically from the cloud operator side, and what we, let's say, offer or sell to our clients, we feel basically 1-to-1 ratio, like we are not losing any feature, which we previously did offer with CEPH and NFS or non-managed storage. I will skim through these slides really quickly because we already talked about them. We are running public cloud, so it's not private, it's public stuff. You cannot control what customers do. They rely heavily on snapshots, but we already mentioned it take hours, and these are not really truly snapshots because they are volume copies. We even internally renamed the feature to volume backups, not snapshots. And basically, so on and so forth. We mentioned all of this. How we basically solve this with SolidFire, basically snapshots on SolidFire stay on SolidFire. It's true as well for NFS and CEPH, but CloudStack will then copy over the volumes. But with SolidFire, there is a difference. These snapshots are not copied over to secondary storage. This is a huge difference. They're all referenced, and you work directly with snapshots on primary storage, which is, I believe, something similar or possible with Zen, with a non-managed storage. So you reference and do everything directly on the primary storage, if I'm not mistaken, but I'm not a Zen guy, so if I'm wrong, sorry for that. For these are obviously real snapshots. It takes literally 3 to 4 seconds to create and restore from very easily. They don't consume almost no space, not literally, but almost no space, and you don't need to move and write hundreds of gigabytes basically to the secondary storage. They are 3-4 seconds, so you can start your virtual router there. So in the next part of the presentation, we have 5 demos, but I'm not going to do them, obviously, due to time constraints. This is a very short one, but basically I kindly ask you to view it at your own pace. The presentations you can download later, and there will be also links at the last slide. I'm not sure how it works here on the Mac, Mike, but how you play the embedded YouTube? Okay, this is the embedded video YouTube that you will load directly from internet. For some reason, it's not displaying, but
You want to display it on the website? I have it on the...
I have the links, yeah.
You have the links?
Yeah,
Just do it that way?
Yeah, but this one we are going to skip anyway, but you can actually, in this previous, you can see how you create a snapshot with some important data. You artificially produce data damage, you lose some data, and then you revert. It's literally 3 minutes to reproduce the whole thing. It's very simple, it's very fast, it's very efficient, it's nice, very short actually, nice demo, so please take a look at it later. Now we're going to do a demo as well on the quality of storage. We already mentioned all these, let's say, issues or limits of the hypervisor level quality of service on CEPH and NFS volumes, and basically how we solve them. We leverage what is actually the foundation of the SolidFire. They're all built around the quality of service. We guarantee performance per volume, and that's the minimum IOPS, but basically client will usually get more, always get the maximum IOPS if the cluster has enough free resources. And there is also one very big critical difference here is in non-managed storage, or let's say in NFS CEPH, there is no easy way to actually monitor your cluster performance. How do you know if your storage cluster becomes too busy that it degrades the performance? It's impossible to know, but with SolidFire you actually have basically the perfect monitoring environment where you can actually see if you need to add more space or more IOPS for that matter. So this is a quick demo which we are going to do. I'm going to probably actually need your help, Mike, please. I also have the links at the last slide.
Oh, sure. You want to...
As you like.
So here, let's exit out. We'll go over here.
The presentation was made on Windows, and for some reason it's not displaying them on Mac. Yeah. So, yeah, the second one, please. You can open it. Yeah.
So let's copy. I'll come back.
Yeah. I'm going to mute, yeah. Sorry for that. So basically here I'm going... What happened? It's not displaying the output. First screen, second screen.
So the screen isn't displaying. Do we? Oh, is it? Oh, I understand. Like this?
All right.
Maybe that's not it.
It was there, but it takes time more.
Oh, I see.
Right?
Okay. This one's going to the left. Try the right.
Something happening, yeah. Yeah.
Oh wait, now we got it. How do I actually?
You can move the mouse and watch over there.
Oh, that works.
And if you can just rewind the video, please. Yeah, sorry, some technical issues. Too much of them. So we have a demo VM. Basically, I'm going to show you differences between hypervisor level quality of service, how it's implemented, and SolidFire. So we have a root volume, which is on an NFS, freshly deployed VM. If you do the virtual dump XML, you can read the IO-tunes section, which says read bytes, write bytes. That's the part where you actually generate part of the XML. Please do it at your own pace later. But yeah, that's when you consume hypervisor level quality of hypervisor type quality of service. Basically, when you define certain limit to reads and write rate that is basically sent to the XML file that's generated inside libvirt. Now, if we briefly attach a few data volumes which I just pre-created previously to the same VM, we will see the differences between SolidFire and the other data volumes pretty quickly. Yeah. So you can basically check the VM just to make sure that all volumes are attached. By the way, these videos are with sound, so you can view them, normally on YouTube. So back to the hypervisor, we can check inside the VM. We see now we have total 4 drives, 3 of them hot plugged. First NFS, CEPH, and then SolidFire data volume. If we do the widget dumping XML, we still have the IOTune section for root volume, but it's missing for 2 data volumes, NFS and CEPH, and it's missing by design on SolidFire volume. This is the last volume which we attached. So basically, we're just going to briefly stop the VM and start it so it picks up the proper parameters from CloudStack database and generate proper XML. While the VM is stopping, I will basically show you very briefly. This is SolidFire GUI. We have our quality of service volume, which we created, minimum IOPS, maximum burst. So you set certain IOPS limits per volume, and this is a difference. There is nothing set on the hypervisor side, no throttling, nothing. We do that on storage side. VM is being started, and basically it will now pick up the different the different parameters. Yeah, it will pick up the different parameters. Basically, let's just copy the command, and yeah, you can see over here, now I repeated the same version of XML command, root volume, data, all have proper iTunes sections. SolidFire is missing the one. Mike, I would need your, probably your help again, just to switch back to the presentation. In the rest of the video, you can see how you defined hypervisor versus storage quality of service, but I am informed I'm a bit short on time, so I want to do a more interesting demo. This one is kind of basic.
You have to scroll back a little bit.
Okay, yeah, so we did this one. Now, the important topic is basically migration from non-managed storage NFS to SolidFire. You basically have SolidFire ready, new cluster, new volumes are being provisioned there in whatever way you implemented this via these offerings. But then how do you migrate the volumes? You can do offline storage migration, which is logistically not really possible due to downtime. You need to organize downtime, or you can actually do the online storage migration, which is something new that Mike implemented 4.11. We are using it backported to 4.8. There is nasty bug. Please be aware of this with certain version of Livert. And VM volumes are basically being migrated or actually mirrored in parallel on a block level. And at some point in time, which you will see in the next video, the VM is being eventually also live migrated. But we have what I mentioned previously, the busy VM issue. When this part is basically done, the volumes are live migrated, online storage migration is done, then you hit the VM live migration to another host, but if the VM is busy, it will never complete. So Mike did a great thing by implementing this, but it renders it useless if you have a busy VM. So we implemented Qemu, making use actually of Qemu Auto-Convergence through the CloudStack with a code and global parameter. It requires a newer version of Qemu because it implements dynamic auto-convergence intelligently, throttles more and more. With Qemu, with all the versions of Qemu, let's say the regular auto-convergence is not really useful at all. So this is purely the demo, which I'm going to skip, just auto-convergence versus busy VM. We are going to do super demo later. Then we have online storage migration, which is analog to vMotion or ZenMotion stuff consumed from CloudStack. This is not new in Livert and KVM, but there was no support so far on CloudStack. So basically, this is just the bare functionality demo, which we're going to skip also. And now I'm going to do a next demo, which is a super demo of these two, but with a very busy VM and a very busy storage. And explanations you can read, but I will tell them during the demo. So Mike, jump in, and I'm done after this demo. We had a bit of last one.
This one here?
Yep.
Escape. Okay, yeah, I got it. Last one, right?
Yep. Good. Thanks, Mike. So basically, obviously, you log into your environment, and the original demo is 46 minutes, but I will explain it in 6 or 7 minutes total. So we have a demo VM. Let me just put into full screen. Okay, good. So you can observe this is a 24 CPU VM. We observe a host on which it's running. We can observe volumes of this VM. We have a root volume which is not relevant. It's on SolidFire. We don't care for the purpose of this demo. But we do have 2 additional data volumes, which are 2 NFS volumes of 100 gigs. We are going to do software RAID 0 across 2 100 gigs and write with 150 megabytes per second to produce a busy storage. And then we are going to do a similar with a CPU and RAM. So this is just volume overview. You can see both of them are on NFS. And then if we go to the hypervisor level, this is a source host. We have a VM running over here. We also have a destination host, because when you do online migration, storage is moved, but also the VM is live migrated. On the destination host, there is no VM running. On the source host, during the migration, which is not yet started, we will observe the progress of the live migration, RAM memory live migration. We are also going to observe in another tab, also on the source host, the block level jobs, which is basically the online storage migration progress. These are 2 NFS volumes which are being mirrored, which will be mirrored or migrated actually to SolidFire. Inside the VM, we are using the stress up test utility from Google, writing to 59.5 gigabytes of RAM. 24 CPUs will be busy absolutely for 100%. On storage side, we see we have 2 data disks of 100 gig. You can see we have active RAID 0 on top of these 2 volumes, with a total size of, let's say, 200 gigs. And we are going to use the FIO, whatever you spell that, utility, which probably you are familiar with. That's benchmark utility. But I am rating this or capping this to 150 megabytes of writes. This is purely write to the storage, because this is dev environment. So we are not really unlimited performance-wise. 0 CPU usage at the moment, 0 with IOStat, 0 disk usage across the software RAID, everything 0. So basically we'll now start, we'll now produce a busy VM. This is stress up utility that makes a VM busy in sense of RAM changes. It's just coping over RAM memory pages, really with a crazy speed. We are starting FIO, we are writing with 150 megabytes, you can observe over here per second. And it takes some time to build up this, but basically we will now observe all 24 VM CPUs are 100% full. And basically we can observe that with a virt top utility, we can observe physical host CPU utilization. This is 24 CPUs out of 32, so roughly 75%. In a separate demo, you will see how this percentage goes down as the VM is being throttled by dynamic auto-convergence. You will see it in much more detail, so please make sure you view it. It's a very interesting one. We are using the CloudMonkey command for now. Online storage migration is available only via API call. This is a new migrate virtual machine with volume. We are referencing virtual machine ID, host ID to which the VM will be migrated, and then migrate 0 pool, migrate 0 storage, migrate 1 pool, migrate 1 storage. So we're telling them these 2 volumes, volumes, not storage, volumes, migrate them to this same pool in these cases. Theoretically, it could be 2 different SolidFire clusters. We started the migration job. We wait for a few seconds so it really kicks in on the hypervisor level. It's now still, let's say, building up. So the block level copy progress or the volume mirroring from NFS to Ceph or online storage migration, if you want, is starting obviously from 0%, and we're being progressing. If we check the destination host, we have a destination VM which is in pause state. It has the same XML file, except the difference that it's not referencing NFS volume, it's now referencing SolidFire volumes, and the RAM content is being copied over. This is SolidFire GUI. I'm basically here, these 2 new volumes which have been automatically provisioned as parallel to the 2 NFS volumes. I'm just increasing the maximum EOPS for these volumes to speed up the migration process. And for both volumes, let me skip for 5 seconds to save some time. And then we can observe in the reporting tab, you can observe volume performance. Here you can see very granularly per volume actual current performance. It's still building up, it refreshes every 10 seconds. But basically, I now configure a split view. The video is paused and continue to be recorded a few times. So if I scroll down, you will see different percentage going up. But all the time, while the block level jobs are running, basically the copying of the NFS to SolidFire, you will also see certain throughput on the SolidFire storage being written to as a part of the migration, obviously. And you can observe this until you get bored to tears. Later, I switched up to this different view. Still, it takes some time to finish block level migration. When it reaches 99 point something percentage, then the VM live migration will kick in. So now I'm going to rewind to 27 minutes. You have this number in our presentation, so you can rewind yourself as well. And after that, the live migration will kick in, and we'll be very soon done with the presentation. So it rewinds faster on Windows, just to tell you the truth. But it doesn't work. So when the volumes are basically 99 point something percent done, KVM will decide at some point to kick in with the live migration of the VM, which is RAM memory live migration. And here you can observe memory bandwidth, which is copying rate, and so on and so forth. You can observe number of iterations. This will climb to 20 iterations because first iteration it will fail, then Qemu will throttle the CPU, then the second iteration will also fail. It will throttle more and more and more and more, basically until you reach some 20 minutes later. Basically, it will go to 26 iterations as the CPUs are being throttled more and more and more, and then throttled actually enough that these 24 CPUs are throttled, so it's not busy anymore that much, and it will basically finish eventually. This took actually 1.5 hours without any video recording, but that's pretty much it. At some moment, the VM will finish the migration, and it will disappear from this source host, which is basically now. I'm done in literally 1 minute, so sorry for that. Can you just run the slides? Okay, 30 seconds. So here you can find some links, direct demo links, which are also part of the presentation embedded. Some other links from Mike, what to expect with Ceph and so on. And there is a small bonus script from HIAG, which we use internally to say, have this VM, have it migrated to SolidFire. It will find all the volumes which are not on SolidFire and migrate them over. Sorry for all the technical issues. It's beyond our...
I just wanted to point out that his videos some of them that we did see and some that we didn't see, he has them all narrated nicely. So if you do watch them online, it's not just a silent video. Everything is explained nicely. So I really do encourage you to take a look at those. And he put a lot of great work into making those videos and providing great explanations. So go ahead and check them out if you can.
Thanks.
Okay, thanks guys. Yeah, it was unfortunate we had some technical issues. If you have some questions, just ask the guys during the break. Thanks a lot, guys.